The Sally Breidegam Miksiewicz Innovation Award was created in 2015 to honor an industry thought leader. Sally believed that innovation was a vital part in moving the industry forward and increasing customer satisfaction. The Sally Breidegam Miksiewicz Innovation Award celebrates innovation in equipment, processes, services, and products that advance the lead battery industry. Battery Council International received 11 submissions from these companies. Today, we will showcase the video submissions in their entirety to give the participating organizations full recognition of their innovations.
Apotex is a leading manufacturer of battery monitoring systems for all battery technologies. This last patented development closes the loop between the battery and charger. The battery can communicate completely wireless with the charger and transfer all relevant battery data for the optimal charging regime.
When a charger is connected to a battery within a group of batteries, the problem is to identify which battery has been connected to the charger. For this identification, Apotex Technologies has come up with a novel idea. When a charger detects that a battery has been connected, it sends a series of defined current or voltage pulses through the power cable. The charger then asks all the battery's management systems which battery has detected these pulses. The battery which receives these pulses transmits its identification number and starts the wireless communication with the charger. The latter then adapts its charging profile accordingly.
A perfectly self-regulated charging regime saves energy and enhances performance and operational life of the battery. It gives the maximum flexibility to the operator as no dedicated charger per battery is required. Here is a brief demonstration of a typical setup. Here are some of the main advantages. Battery life is significantly extended. Energy and time are saved during the charging process. Adaptable to any charger with any voltage and current. Quick and easy setup. And all battery history is logged and stored.
Last year, Battery Rescue expanded its unique battery collection service to remote West Australian mine sites. West Australia has a large remote mining industry where wood pallets are the most common method used for transporting used lead-acid batteries for recycling. Pictured is a typical shipment from a BHP mine site. This does not comply with the Australian Code for Transport of Dangerous Goods, and we estimate that 95% of shipments would be non-compliant from Western Australian mine sites. What mining companies such as BHP want is a solution that prevents acid leaks into the environment, is a safer method for storing and transporting their batteries, is more convenient and reduces their risks through regulation compliance. As part of Battery Rescue's collection service, we provide our customers with the unique BTS container. The BTS container features safe ergonomic loading and a bunded base to capture any acid leaks. Pictured here are two full BTS containers at a BHP mine site, closed and ready for immediate transport to the nearest battery recycler. Critical to providing this service is being able to effectively manage the logistics of transporting BTS containers to and from the mine sites. The addition of battery-powered 4G IoT devices and browser-based software platforms has enabled us to efficiently manage our container pool, has prevented misplacement or losing containers, and in the event of an accident or fire, alerts are sent.
Calvin, and I'm representing Customized Energy Solutions. So, on site, on microgrid sites, we have observed that the degradation of batteries it's much more rapid than what it's supposed to be. This is mostly observed because the technicians on site they're not very well informed and technically skilled. So in order to tackle such issues, we have set up a similar system in a lab in a college called as Miksiewicz College of Engineering. So we are currently in the lab. I'll just take you through the setup. So we have two sets of solar panels on the rooftop, each of 1.5 kilowatt rating, and those connections come directly to these two solar charge controllers. These are PWM style charge controllers. The output of these charge controllers is given to the inverter. It's a hybrid inverter, so it has input from solar, output to these battery pack. So it's a 48 volt 100 system. We also have a programmable charger. This is for special tasks such as equalization and stuff, which is out of scope of this inverter. So we use that to help improve, find out what is the best operating practices. Then this inverter, it's also connected to a load bank. So this load bank helps us to maintain output current, and also it's as it simulates a constant current load or a variable current load. So that's basically all of it. Then we have multiple such meters that measure the voltage, current, and temperature of these battery packs, and it sends the data over to the cloud, and we can get the data represented on a web browser on any PC in the world. So that's currently running. So we have lots of data that we acquire, and we process that data, and hence we have been successful in building the operation and maintenance.
Duramic has been an industry leader in the manufacturing and supply of battery separators for nearly 90 years. Starting with a single plant in 1930, Duramic now operates in 10 locations around the globe and is backed by leading conglomerate Asahi Kasei. On all types of parkways, paths and aisles, vehicles and the lead-acid batteries they carry are moving. A key to understanding how the battery functions, including its failure modes, is to mimic real-world scenarios. Introducing Duramic's latest contribution to the industry, the Duramic Shuttle Table, brought to you by Huff Technologies. Duramic, in partnership with Huff Technologies, has developed a proprietary testing method and machinery that act as a paradigm shift in how batteries of all types are tested in motion. Improving on the current motion testing methods, such as the traditional rocker table, the Duramic Shuttle Table allows testing of up to 12 Group 31 batteries simultaneously. The versatile T-slotted rail system allows for quick and adjustable tie-down of the batteries in multiple configurations and sizes. Access to circuits is made easy through a clearance gap on the top of the table. Featuring an advanced control panel, technicians can program desired testing parameters, including acceleration, time between movements, and cycles. Additionally, data is collected with the computer, which can be easily transferred using the USB ports located on the machine. Duramic continues to drive improvements to lead-acid battery design. Better testing methods are a part of that journey. Duramic, keeping the world in motion. As Canada's leading environmental services provider, TerraPure Environmental is invested in making lead-acid battery recycling safer as more lithium-ion batteries make their way into the mix. The danger for lead recyclers occurs when lithium-ion batteries, which often look identical to lead-acid batteries, accidentally enter the battery breaking process, where they can explode, causing harm to personnel and equipment. As the number of lithium-ion batteries increases, it becomes more difficult to separate them from the lead battery recycling stream. That's why TerraPure created a detection device called the lie detector. The lie detector uses high-frequency radio waves to detect lithium-ion batteries by scanning for their unique charging and protection circuitry. Even when unpowered, the circuitry can be easily detected. Whether permanently mounted or handheld, the lie detector is deployed at the front end of the lead recycling process. If lithium-ion batteries are found, the lie detector emits a signal that can be used to trigger an alert or an automatic response. Although we'll see more lithium-ion batteries in the future, safety will never be a thing of the past. TerraPure's lie detector is the first step in safeguarding your personnel, your facilities, and your bottom line.
I'm Sepper Mogari, and I'm the co-founder of Voltific. Voltific is a cloud-based battery lifecycle optimization platform which allows engineers and technicians to get the most out of battery health. The battery industry is struggling to quantify battery capacity very well. It's very difficult to compare batteries. The other problem is the batteries are complex. They're chemical soup. It's very difficult to know what's going on inside. Our company is going to change the world by tackling one of the biggest problems around batteries, which allows a full adoption of solar and renewable energy sources and reduces the carbon footprint on a global scale. What gets me excited is the fact that we can actually make a change. We can see it in our skills, we can see it in our technology, that we can have a big impact on the future of batteries and in the world.
Over its 80-plus year history, Microporous has established its reputation for quality and innovation, offering the broadest line of high-performance battery separators to a global customer base. With manufacturing plants in Austria and the US, Microporous can supply the broadest range of high-performance separators in the world. Microporous R&D Center is staffed with over 250 plus years of combined experience, which is continually improving our current product offering, but is also keenly focused on developing game-changing technology for the next generation of lead-acid batteries. Today, we see the increasing scrutiny of carbon dioxide emissions, which has created an increasing demand in start-stop technology. Start-stop technology has been in use for the past 10 years and has created additional electrical demands that a standard SLI product could not support. So the Enhanced Flooded Battery, EFB, was born. As demand for start-stop vehicles grow, the need for EFB will continue to increase around the world. The key issue that continues to surface is the need for higher charge acceptance and enhanced cycling at a partial state of charge. Microporous is therefore presenting a high charge acceptance enhancing separator component that features a unique formulation of high surface area carbon and other additives for faster charging. The Microporous DCA Booster Mat is a charge acceptance enhancer consisting of an engineered separator component. By incorporating the carbon layer onto a non-woven mat, the innovation allows for a convenient and versatile application method. The data shown in the bar chart indicates an increase in DCA for a conventional EFB of up to 300%. The microporous booster mat has been designed to be completely compatible with all lead-acid battery separators. The team at Microporous wants to thank you for your time and attention.
lead battery has been the dominant energy storage technology for over 150 years. In telecommunications, automotive, and energy storage, lead is the workhorse. Society is looking for improvements in energy consumption, better environmental performance, and of course, recyclability. the lead battery dominates that technology. RSR Technology strongly believes using modern scientific techniques, we can improve the lead-acid battery to be an active player as the world goes forward.
RSR Technologies has developed super soft high cycle as an active material alloy and 009 as a new grid alloy to improve lead batteries. Our focus has been on using high-class instrumentation and techniques to explore these materials in ways they've never been looked at before. To increase our understanding of how our alloys work, we've partnered with Argonne National Laboratory to validate the findings that we see in lead batteries. We've focused on crystallization processes like lead sulfate growth and dissolution and how they change using our alloys and how they tie to important characteristics like cycle life, energy density, and DCA.
RSR Technologies has heavily invested in analytical capabilities that have allowed us to further understand and fully characterize our highly advanced alloys and highly refined secondary leads. Techniques like ICP mass spec give us the ability to characterize dopant elements in alloys such as 009 and super soft high cycle.
In partnership with Willard Battery in South Africa, RSR Technologies has brought super soft high cycle and 009 to market.
The super soft high cycle alloy that has been developed by RSR and supplied to us through Fry's Metals have enabled us to meet those drivers coming from industry. The implementation of the super soft high cycle alloy, we've been implementing that in all our commercial products. What we found, huge improvements in the cyclability of the battery. We're currently achieving in excess of 1200 cycles and in certain cases up to 1600 cycles. So from those numbers you can see a vast increase in the cyclic performance of the battery.
In emerging economies, issues of cost and recyclability dominate. With the world population expanding ever so dramatically, bringing high technology to emerging markets is ever more important to assure lead acid's place in providing an economical and equitable life assures that lead acid will maintain its important role in the world energy economy.
These innovations ensure the lead battery industry can meet the energy demands of our world. For applications today and for the emerging technologies of tomorrow, innovation is the key to our future. Thank you to all the companies who have made commitments to innovation.